Hello and welcome back to Tech. In this video, I'm going to show you how to make a Coca-Cola pinhole lantern with using an RGB LED and an AT1085 microcontroller. Let's get started. And these are the items that you're going to need to make for this project. The items you're going to need is an RGB LED common cathode, an AT1085 microcontroller, an 8-pin IC socket holder, a push-button lock switch, a Perfboard, a 3-volt button cell battery, a 3-volt button cell battery holder, and you're also going to need some wire, and a Coca Zero can, or soda of choice. Now let's go ahead and assemble this project, and let's get started. I have right here this RGB LED, and when I light it up, it makes this focus point of light. This focus point of light isn't good for this project because it will focus the light in the center of the cube. I need the LED light to disperse more evenly so it lights up the whole entire cube. And to do that, I'm going to take these clippers and cut off the tip of the LED. Doing that will remove the lens on the end of the LED and will allow the LED light to disperse more evenly. Having a flat top will cause more light to spread out. Having a curved top will cause a focused lens effect, which will cause the LED light to be more concentrated. And there, it should look just like this. A very important note to know is if you cut the LED tip too low, it won't work. So you need to cut the tip a little bit closer to the top. Cut it again. Cut off the sides so it's a little bit more flat and smooth. And now let's test it out again. And as you can see, it now works. Perfect. Now looking at the LED light's now more dispersed compared to a non-cut LED. And you can see the LED light's more focused. I'm going to take the 8-pin IC socket holder and place it onto the Perfboard, just like this. Clamp it down. Solder in the first pin. Remove the clamp. Press down on the IC socket holder and remelt the solder so that way it can be flush with the board. As you can see, not very even, so I need to repeat the same process on the opposite side. There we go, the IC socket holder is now flush with the board. Perfect. Now solder in the rest of the pins. Next, I want to take the RGB LED and I want to connect all of the anodes to pin 5, 6, and 7 and connect the cathode to pin 4. I'm going to take the cathode, put it into this corner so it's separate from the anodes, and then place the anodes into place, just like this. Don't push the LED all the way through because I want the LED light to disperse much evenly inside the cube. And now, solder it into place. Next, I'm going to take the first anode and place it onto pin 5. Cut off the excess. Solder bridge it to pin 5. And now take the third anode and place it over to pin 7. Cut off the excess. And now solder bridge it to pin 7. And now take the second anode and place it over to pin 6. Carefully cut off the excess and carefully solder bridge it into place. Put a very light amount of solder so you don't cross bridges. Next, I'm going to bend the cathode lead in this direction and then carefully bend it into an angle. Solder tin it, and now take a bridge wire and solder it to the tip, and then solder the bridge wire to the pin 4. And now solder the bridge wire to the tip, and now bend over the bridge wire to pin 4, and then solder it to pin 4. Take 2 jumper wires and the 3-volt button cell battery. Take one jumper wire, connect it to pin 4, which will be negative. and connect it to the negative of the 3-volt button cell battery, another jumper wire to the positive of the 3-volt button cell battery, and then touch that jumper cable to all of the anodes. And as you can see, the red works, but it looks a little bit yellow. Ah, that's because it's connected to green. Alright, so I need to make sure those are separated, but the blue works, that's good. The red and green are now connected, so I need to separate those two by remelting the solder. This is exactly why I said be careful when you put the solder, don't put a heavy amount. Putting a heavy amount will cause the two bridges to connect together. As you can see, I placed too much solder, so I need to remove some of the solder. Remelt it, reposition that anode, clamp it down, and there. Now I'm going to lightly put some solder onto the pin 5. And then repeat the test. Red works. Green works, good. And then blue still works, perfect. All of the pins are now separated and everything works. Next, I'm going to place the push button lock switch over to pin 8. Bend over the leads. And bend that lead over to pin 8. And now solder it into place. Remount the solder so it's flush with the board. And now solder bridge it to pin 8. Next, I'm going to take the 3-volt button cell battery holder. This side's positive, this side's negative, and I want to connect the positive over to the push button lock switch. Place it in just like this. Solder it into place. And then solder in the positive pin, and then solder bridge it to the push button lock switch. And there, the positive is now soldered to the push button lock switch. Next, I'm going to take this negative wire, solder it over to pin 4, and then solder the wire over to the negative terminal of the 3-volt button cell battery holder. Connect it to the negative, just like this, and then connect it to pin 4, just like this. And now, take the ATtiny85 microcontroller and place it into the IC socket holder. And now connect the 3-volt button cell battery. And there, the circuit is now complete. Now, let's go test it out. And there, it works. And down in the description below, I have the code to the ATtiny85 microcontroller, so then that way you can make the RGB LED glow like this. Next, take the soda can, and now get something sharp to poke some holes, like what I have on my pocket knife, which is meant for stitching leather. And then gently make some holes. And it should look just like this. And now do the same thing on the rest of the writing of the can. And there, it should look just like this. Yes, I know it's a little dented, but that's okay, you can fix that later. Next, what I'm going to do is take a X-Acto knife and make a slit going across the top. And now another slit going across the bottom. And now make another slit going the opposite direction, connecting the two slits together. And now you can be able to open it up. After you open it up, you can be able to fix the dents. Taking the back of the X-Acto knife and pressing down on the dents. And there, the can looks a lot better now. Open up those slits a little bit more. And as you can see, this top part here, where you normally drink the beverage, I'm going to go ahead and close it up. Press it down. And there, it should look just like this. What I'm going to do is open up this a little bit more, so that way it's easier to access. And there, this part is now complete. Next, I'm going to take some electrical tape and take a piece of electrical tape and cover up this opening of the can, so that way no light will escape from there. There we go, that's good. Press it down carefully. And there, it is now covered. And there, as you can see, this looks very nice. Next, I'm going to take some electrical tape and place it on the bottom of my circuit, so that way when I place the circuit inside the can, it won't short from the can. And now close it up, and there, the project is now complete. Now let's see how this looks in the dark. Ah, as you can see, this looks great in the dark. A very nice, relaxing looking lantern. Wow, this looks really cool. I really like this. And there you have it. Now you know how to make your very own Coca-Cola pinhole lantern with an RGB LED and an 801085 microcontroller. Thank you for watching SciTech Tech. I hope you learned something new, and don't forget to like, subscribe, and of course click on the bell icon to be notified for future SciTech Tech videos. Till the next tech, goodbye.